Hello everyone, I am Christopher Desal. So our topic is all about the nano world. So the first thing you need to do is what is nano world? The nano world is the world of extremely tiny particles, so small that they can only be seen with a powerful microscopes, where materials show unique properties and behavior. So nano world is like a hidden mini universe that exists far smaller than with our eyes can see. So the easy way explanation about nanoworld is that if we think of a grain of sand, now we imagine cutting that grain of sand into a million tiny pieces. So each piece. So in this world, everything measured in nanometers. 1 nanometer equals 1 billionth of a meter. So a human hair is about 80,000 to 100,000 nanometers thick. At the nano world level, things are the thinner than a virus. So we can imagine that the virus, we can see a virus through our naked eyes. So we can see the virus through microscope. So what makes the nano world special? So if we imagine that the nano world, like materials can change behavior. So the object can become stronger, lighter, or more reactive. So basically science can control atoms and molecules. So just it's just like a part of a nano world. So for an example, gold in a normal size is yellow, but gold in a nanoparticles can appear to red or purple. So this happens because matter acts differently at the nanoscale. So in short, when we see gold in our eyes, so it's color yellow. So in a nanoscale, so it's something purple. So in a simple real life examples of a nano world like a sunscreen, I know we use sunscreen. A nanoparticle, so it looks like clear but still black UV rays. So when we apply sunscreen, so it looks like white, but in a nano world, it's like it still blacks in a UV rays. So phones also use a nanotechnology to make chips faster and smaller. So and also the medicine uses nanoparticles to deliver drugs directly to sick cells. So if we drink like pills, there are nanoparticles there to make the pills effective in our body. So that's all about nanoparticles.
The nano world refers to things that are extremely small, about 1 to 100 nanometers, and many of them are already part of our everyday life. Here are common nano world examples to see today. Number 1. Health and medicine. Sunscreen uses nano zinc oxide or titanium dioxide to block UV rays without looking white on the skin. Medicines. Nanoparticles help deliver drugs directly to disease cells, like in cancer treatment. Number 2. Everyday products. Clothing and socks. Nanosilver particles prevent odor by killing bacteria. Cosmetics. Nano ingredients improve absorption and smoothness. Number 3. Technology and electronics. Smartphones and computers. Nano translators make devices faster and smaller. Number 4. Household items. Self-cleaning glass use nano coating to repel dirt and water. Antibacterial sprays and detergents contain nanoparticles that kill germs. Number 5. Environment. Water filters. Nanofilters remove bacteria and heavy materials. Number 6. Food and packaging. Food packaging nanomaterials help keep food fresh longer. Food additives. Some use nanoparticles to enhance color or texture. In short, even if we can't see them, Nanomaterials are already improving our health, technology, and daily life.
How important the nano world in our technology? The nano world is important to modern technology as it enables the manipulation of matters at atomic and molecular levels, leading to materials and devices with revolutionary new properties. This manipulation provides enhanced properties such as a greater strength, lighter weight, increased conductivity, and heightened chemical reactivity that are often dramatically different from those same materials at a larger or bulk scale.
The 10K concept of the nanoworld. First, nanoscale or size matter. The nanoworld deals with objects that are 1 to 100 nanometers in size. At this scale, materials behave differently. For example, imagine a marble is the size of a basketball. In that comparison, a nanoparticle would be as small as a grain of sand on the basketball. Because it is so tiny, it can do things big objects cannot, like pass through seals. Second, surface area to volume ratio. Nanomaterials have a very large surface area compared to their volume, making them more reactive. For example, compare a sugar cube and powdered sugar, which dissolves faster in water. Powdered sugar dissolves faster because more surface touches the water, just like nanoparticles. Third, quantum effects. At the nanoscale, quantum physics become important. Electrons behave differently, affecting color, conductivity, and energy. For example, gold in bulk is yellow, but gold nanoparticles can appear red or purple. This happens because electrons act differently at the nanoscale, changing how light is absorbed and reflected. Fourth, size-dependent properties. Changing the size of a nanoparticle can change its color, strength, conductivity, or melting point. For example, think of Lego blocks. A big Lego structure is stable, but tiny pieces can move easily and fit into small spaces. At the nanoscale, can bend, stretch, or react in new ways. Fifth, self-assembly. Nanoparticles can organize themselves into patterns without human control. For example, like magnets snapping together automatically, nanoparticles can arrange themselves into useful structure such as drug carriers, or electronic circuits. 6. Forces dominate. Van der Waals and electrostatic forces. At the nano level, gravity is weak and other forces become more important. For example, a gecko can walk on walls because millions of tiny nano-sized hair on its feet stick using weak forces. This inspired nano-based adhesive. 7. Nanotechnology in medicine. Nanoparticles can target specific cells, such as cancer cells. For example, imagine a delivery drone that goes only to one house. Nanomedicine works like that, delivering drugs directly to sick cells, reducing side effects. 8. Nanotechnology in everyday life. Nanotechnology is already used in daily products. For example, sunscreen uses nanoparticles to block UV rays. And another example is clothes use nano coating to repel water and stains. 9. Bottom-up versus top-down approach. Top-down, breaking big materials into nano-sized parts. Bottom-up, building materials atom by atom. For example, cutting a paper into tiny pieces is top-down. Building something using Lego bricks is bottom-up. 10. Ethical and safety concerns. Nanotechnology must be used responsibly because nanoparticles can enter the body and environment. For example, just like medicine needs proper dosage, nanomaterials must be careful taste to avoid harm.
Application of the nano world. Here are the 5 application of nano world. Number 1 is medicine. Targeted drug delivery or cancer treatment. And medical coatings. Second is energy. More efficient solar panels and better batteries and fuel cells. Third is electronics. Smaller and faster chips and flexible screens and wearable devices. Fourth is environment. Water purification using non-filters, pollution control and cleanup. And last is consumer products. Sunscreen with nanoparticles, stain-resistant fabrics, stronger sports equipment. What are the branches and application of nano world? The nano world or nanotechnology and studies and manipulates matter at the atomic scale 1 to 100, with branches spanning material science, electronics, medicine, energy, and environmental science. Here are the 5 branches of the nano world. Number 1 is nanomaterials. Focuses on creating and studying materials at the nano scale. Example is nanoparticles, carbon monotubes, and graphene. Second is nanoelectronics. Deals with electronic components made at nano scale. Example is monoscale transistors, quantum dots used to make devices faster and smaller. Third is nanotechnology or nanomedicine. Applies nanotechnology to biology and medicine. Example is drug delivery or cancer treatment. And fourth is nanomechanics. Studies mechanical behavior of nanoscale system. Nanosensors or nanoactuators. And the 5 is nanophotonics. Involves light interaction with nanostructures.